didn't see anything. Okay, let me, let's do this thing. So last time I left off, I think I had this website working pretty well. Let's bring it back up so you can see what's going on. And over a little bit of time, I actually did a bit of math to figure out how to do this in projection. And I just want to say that this was one of the most difficult things I've ever done in terms of like just wrapping my head around everything. So this is easy. This is orthographic projection. So every line that you see, like you can imagine, like every line coming from your eye is in the exact same direction. But if for perspective projection, that is not the case. That is not the case. And to figure out how exactly to render a circle in 3D space onto a screen it's not easy. It's not easy. But let's start with the circle 3D circle rendering onto a screen. So first we need, did I put it? Wait, are you kidding me? Did I not write it down? Oh, okay. Is that right? Let me see. I also have this written down elsewhere, but it is a mess. I had to pull in a bit of help from a few intelligences to figure this out, but I didn't write any of the code with the wait, what the fuck? Ah, shit. Okay, well, I wrote this for this thing, and I assumed that the circle would not be rotating in multiple directions, but I guess it will be. So this is fun. These okay, good. So these equations don't even fucking match up now. That's good. Oh my gosh. Okay. So this is what I'm looking at, by the way. It's insane. Great. Now I need to show that all of these are actually equal. Fuck. Okay, whatever. I'll actually code this so make some progress. So what I'm gonna do is I'm gonna go into pages or app, cd into app weights. So we just have this page.tsx. If we open up this page.tsx, I'm gonna go ahead and just add a new div. We'll call it perspective plates. Yeah, it's ugly, but whatever. And then this guy will be I think we just want like a big square for now. And let me just figure out how to actually do this. Import perspective plates from tilde slash, let me actually make that VI perspective plates. What's the, I'll call it engine or something. Okay, export default perspective, that's not gonna work. Export perspective plates is equal to, it takes something and then returns, you can return a div for now. Return div, just do this for now. Height 50px and weight, not weight, length, width. I'm so messed up. I don't know. This was not easy to figure out. Background red. Okay, I'll just return that for now, and maybe that's all we need to do. No, it's not. Unfortunately, it is very much not. Oh, we need to save this to from ./engine.tsx, and we just need to do this, and we should have it. No. Expected blank got indent. Oh, yeah. Of course. Okay, so there's our fucking thing. So now all we need to do, I'm gonna do this completely separately from this whole weights visualization for now. So we'll turn that off. But we'll just give it kind of free reign. All we need to do is pass in the weights. So weights is equal to use plates, and from there, everything else can be figured out. So let me just print them out. Const plates is equal to props dot plates. Explicit, and we have props. TS, when I actually try to compile it, it's going to complain, but that's okay. Alright, fair enough. Or it's weights called. It's called weights, isn't it? Yeah, weights. The plates actually need to be rendered. These are just the raw weights. Okay, cool. We just have a 45, and it still works here. We have a 45 and a etc. etc. Okay, so from there, we can do everything else we need to do. So let me go ahead and do, we don't actually need to touch this guy at all. Okay, first things first, let's, okay, we need to go all the way back to the start and just figure out what is the, actually, I'll bring back the other one, like that one. Just turn this off real quick. Okay, so the thing we need to render, or we need to figure out in 3D space, is what is the, so we have a few circles here. That's the whole, this is why I did all this work, to figure out how to render a circle. It's an ellipse. It turns out to be an ellipse, but what exactly do we need? We have 4 circles. We have this one, we have 2 outer ones and 2 inner ones, and there's going to be some like layering I'll get to when I get to, but for now let's just start with with one outer circle. So the formula for the center of that is pretty simple. All we got to do is oh wait, you know what I just thought of? We do still need something very similar to this whole depth. Wait. We do very much need this raw radius, and oh my god. Okay, we do need to copy a bit, or we could just save it to a common spot. I think I'd prefer to save it to a common spot, so let's do what do we need? What do we need exactly? We need color. So color can be this whole thing. So we'll do export const get color is equal to, what do we just pass in? Weight and unit. Yeah. So weight number unit string or whatever. Yeah, unit string, and this is going to pass back this whole thing. We can just, we'll need to copy that like so. We have a fallback function too, which is cool, and that should do it. And then just return color, and that should, now we can just do import get color, and I'm also going to go ahead and throw in get diameter and get width. This is not going to compile for a little bit, but that's okay. For diameter, we do this thing, very similar. Export const get diameter. Diameter is equal to weight, a number, unit, a string. There we have it. Return raw diameter, and so it'll all be in the same place. We'll just have to do it differently, and then get width, same thing, like so. Yeah. Export const get width is equal to weight number unit string. I'm starting to think that we should probably combine these into a single get properties, but whatever, we'll hold off on that for now. Return raw width, and just replace those. We'll do like color string is equal to get color unit weight, or is it weight unit? It's weight unit. Weight unit. Okay. Get rid of all this, and then let raw diameter is equal to get diameter weight unit, and let raw width is equal to get width weight unit. All right. And get rid of all this, and hopefully that should still work. Nope. Cannot find LB. Why not? Do we need this here? Okay. Okay, here's what we're gonna do. Vi constants dot tsx, or I don't know, like shared, common. We'll call it common tsx. Okay. And we'll do export, and we'll just copy these in. And we'll do export kglb from common. Okay, here we go. And we'll do the same exact thing here. Copy that into engine. There we have it. No, doesn't like that. Can't resolve common because we didn't save it. There you have it. Alright, cool. So everything still works. And we can now access everything that we need. In fact, this isn't strictly necessary to this perspective thing, so I'm actually gonna move this into common as well. Just keep this more pure for just rendering stuff. Okay, cool. This is gonna change a few imports. So get color, get diameter, get width. All right, and then we'll need this exact same line in page, and we can get rid of these. All right, and that not quite. Don't need to redefine it. Okay, there we have it. Okay, cool. Next step. Okay. Let's just, there's going to be a lot of math we need to do before we even get to any div stuff. So here's what we're going to do. Let's just start with the first weight. So whatever weight gets passed in, weights 0. Okay, so this is a weight. We can also do const diameter. I'll call it I'll call this R, or circle radius is equal to get diameter we do need to pass in unit now. Get diameter weight units unit is equal to unit. Okay. What? Fuck you. Oh, I do not like how it's doing that. That is really annoying. Okay, now it's not doing it. Whatever. Okay, so we have circle radius. I'm just gonna keep logging these as we go. Circle radius. Big old debug thing. Okay, so circle radius is get diameter, weight in unit. That's useful. We also want const circle width. Oh, this is divided by 2. Const width is equal to get width weight in unit. Sure. Color we'll come back to. That's much later. And you know what, I think we do need theta, so const rotation, I think I just call it theta is equal to props dot theta. And this one keeps changing. I know it looks like it's rotating really cleanly, but it's actually just, it's a callback. It's running in like a set interval. Okay, so now we can do theta, and this should keep changing. Yeah. Okay, fair enough. So that's cool. We have this theta that's changing. But I think I'm actually just gonna do this for now. So let theta is equal to like 0.4 or something. Fixed value for now. Okay, we have weights, we have circle radius, circle width, we have that. The only thing I do want to do is how are we actually going to place these circles in the 3D space. So that's going to be, I believe we called it, there should be like a distance from visual depth maybe. I think it's hard coded. There should be some kind of what is it? Hole radius. I don't see any z index here at all. Oh, because it doesn't matter. Because it actually doesn't matter in orthographic projection. Because all the lines are parallel. If you move it on the z-axis, it won't change what it looks like, even if it's like 1,000,000 miles away. So I don't know. Let's just do this. Const center. I don't know if I want to change this or not, but let's just call it center. Center z, and this is going to be negative. I have no idea. We're dealing with pixels, right? So maybe let's just say negative 500, because I'm pretty sure if you pretend that you're the camera, the positive z is this way, so negative z is that way, and you want to have your object that way. So center Z. This with these three, you can actually these three and theta, you can actually get everything you want for this. So let's start with the first circle. This one will be, you know, the equations for these aren't even that easy, I think. We basically need what is it? Shut up. First circle. This one, it's a very easy visual to think about, but I do need to go ahead and take a look at it again. Okay, so we also need to choose the x and y coordinates for this guy. Okay. What I'm thinking is okay, yeah, that's weird. Let me think about this. This will simplify a few things, but why was this not included here? What, is there no y? Oh, this is done completely differently because of we're literally just doing this with, this is literally just divs. This isn't even SVG. Okay, so we'll just choose const center y is equal to 0, so it's kind of centered vertically, and then why is my tab not working? Okay, const center x center x. I want to do since we're gonna have to do these for multiple fucking plates, what I want to do is something like, oh, this isn't even center Z, this is plate center Z, and here and here, and this one I'll just do, let's in the 3D space, let's move them over by, we'll have to adjust this, but it's going to be something like, I don't know, const x between, I don't know, we'll do like 100 or so, and do this will be x between times index. So each one will be kind of spaced out a bit. It's going to look weird for now, but we'll figure it. Or maybe x between minus weights dot length over 2, something like that. That'll center them. Or no, this is plate center x, not plate center x. This one's y. Okay. So now we have the plate center. Now we actually need to get the center points of all these fucking things. So if we have a center and and it's rotated in a certain direction, if we think of the normal, we need the normal vector. We have the things we need are r squared. We need theta. We need cy, cz, and cx. For the center point, it's pretty easy. You just move it out by width in a certain direction. Let's actually figure out the normal vector first, because once we have the normal vector, we can figure out the circle center. So let's do const normal x is equal to const normal y is equal to const normal z is equal to, what are these going to be equal to exactly? I'll tell you right now, normal y is going to be 0, just because you see the y is like up, it's up. So this plate is always going to be like, the normal vector of this plate is going to be like that. It's just going to be, it's never going to have a y component, which is somewhat arbitrary. And we can mess around with this later if we want, but for now we'll just have it like this. For the normal x, this is actually going to be just pretty simple. I think it's, we're going to choose it, let's see, if we're looking at the plate, that's the x direction, that's the y direction. If x increases, if theta increases, it's going to go like this. So x is just going to be cosine theta. And then, z is actually going to be, it's going to start at 0 and then it's actually going to go down. So we're going to do negative math sine theta. This affects the direction it changes, which actually, let me make a note of that. I'm going to say counterclockwise rotation if looking down on plate. And also normal, I would say normal vector is parallel to barbell. So if you take a barbell and you put it into the plate, that's what the normal vector is. It's going to be in the same direction. So the wide part of the plate is going to be kind of at a 90 degree angle to the normal vector. Okay, so we have the normal vector, which is pretty cool. We now just need to do something like this. The first circle is going to be pushed in the normal direction by, I don't know, positive normal, and then the other divided by width, and then the other one is going to be pushed in the other by negative width. Oh wait, wait, we just had, okay. Let me just organize these real quick. And these are also kind of arbitrary. We just chose it to rotate. We could have made it rotate in like some weird direction, like the Earth spin or something. But we have x, y, z, and we have normal x, y, z. So we'll just do, I don't know. We'll call it const big circle center x is equal to plate center x plus width over 2. This isn't circle width, this is actually plate width. Very confusing, I know. Circle, I guess that's like big circle, so we'll call it, yeah, these are for the plate itself. Okay, shut up. Plate width over 2 times normal x, and then we just, same exact thing all here. Now of course the y is also just going to be 0, but this is for, oh wait, no, the y is, actually it's just going to be plate center y. We're not going to move it in that direction. Although, nah, we'll keep it like that. I know it's going to be 0, but whatever. Okay, so we have, let me just see if I can do this real quick. Big circle center x. What? What's wrong with you? Oh, z. Infinity. Oh, that's good. That's what you want to see. No, that's really not good at all. Let me see what happens if theta changes. Maybe it's just some weird value. Okay, that is not very useful. Big circle center x. Why do you not like that? Alright, give me plate center x. You're really funny, you know that? Infinity, okay. Why is it infinity? Because x between is infinity. No, because index is infinity. Maybe? Oh. stop length divided by 2. What am I talking about? Come on. Okay, it's still 0, but that's fine. Index can be 0. Plate center x. Okay, now it's like a reasonable number. Should be... No, it shouldn't be changing because the plate is rotating in itself, kind of. Big circle center x. Okay, that's good. That's good. It should go kind of a little bit around 50 in both directions. Cool. That makes a lot of sense. Make sure y is not changing, and z similar. Also kind of around. Wait. Why is it 500? Oh, because we pushed it way out. Right. Okay. That's fair. That's fair. Next up. Believe it or not, we actually have everything we need to project this into an eclipse, or at least put it into an eclipse formula, which is then very interesting to convert into other stuff. Now let me pull up that formula again, because what I have is something very different, and we're gonna have to do this kind of 4 times with different radii. But you have where is it? Where's radius? Plate radius, which is going to be same as big circle radius. We're going to have normal XYZ, and we have this center XYZ, which I'm just going to rename as a slightly simpler term. So we're going to have const CX is equal to big circle center X, and similarly YZ. I know Y is still 0, but it might not be in the future. We also need, I'm just going to shorthand these, and x is equal to, oops. This can be kind of reused for various purposes. Const r is equal to plate radius, and this is actually all we need. Now I just need to reconcile some of these formulas because I don't really believe these, basically. I'll show you what I have, and then we'll kind of work through some bullshit, because I when I made this, I kind of assumed that y would be 0, and this normal would also be 0, but the more general solution that I came up with, also I was using the theta, not normal, so the formulas look a bit different, but we need to make sure that they look the same. So here's what I have. This is the ellipse equation, which is going to be ax squared plus bxy plus cy squared plus d dx plus ey plus f is equal to 0. And if you do a bit of what did I even do here? If you express, the way to get these values is you express for every point on the 3D sphere, on the 3D circle, you can take like the angle on that circle, and then based on that angle you can determine where what it projects to. And you can get both the x coordinate on the projection, on the plane projection, screen projection, and you can get the y coordinate on the projection, on the screen projection. And then you'll get like a x of t parameter. You'll get like I'll just say these values come from taking some angle on the 3D circle. I'll say circle in 3D. mapping it to point on circle, so take some angle, mapping it to point on circle in 3D, converting, projecting it onto screen plane. Getting two methods, x of angle and y of angle, and then what? Rearranging. You have these parametric equations. Rearranging. So these are actually like very intuitive. Like they're very intuitive to get. Like they make a lot of sense, and you can see them visually too. But then to actually like solve them and convert them into a form, you can use. You basically need to rearranging so that you can do cosine squared plus sine squared equal 1. And then you kind of add these two you transform and add these parametric equations, then grouping coefficients to get the ellipse formula. I'm not going to do it because it took me like 4 pages, but that's the idea. So what do we have? We have const A is equal to, this is not even going to, what are you doing? All right, const A is equal to R times sine theta times sine theta. I'll put these in a comment because this is what we need to reconcile a few things. Minus cy times sine theta times, I'll just say squared. Hold on. Squared. Minus cz squared. Okay, so that's A. Let's go through what we have, and then also the other method I have is A is equal to d squared minus 2. Oh my, these don't even make fucking sense. Okay, I think this is 2 times d times cx times nx plus k, I don't know, times nx times squared. That's just for A. Yeah, these don't look anything alike. We also have this intermediate D, which we can throw in, why not? Easy with the cx times nx plus cy times ny plus cz times nz, which seems to be some kind of dot product. Oh, okay, so this is like the circle plane, kinda. Alright, whatever. So we have this D, and we also have K, which is Cx, I'll say this is more efficient, plus Cy times Cy plus Cz times Cz minus R times R. Cx times Cx, what is this? This is like, this is like a point. This is the distance from the camera to the center squared. And then, actually, maybe I can think about this somehow with like a math. Get the old thing out. So you have the camera, you have the circle, and you have the radius for some reason. And you have this squared. Oh, wait a minute. Then it's like radius square. Oh, wait. So you have like no, this isn't quite hypotenuse. Oh wait, no, wait. R squared. It's like, so k is equal to like one of, if you have a triangle and the distance between, and you think of like the camera is at one side, and okay, if you have a triangle and then you have the distance between the camera and the center as the hypotenuse, and then you have the radius of the circle as one of the other one of the sides of this. So you have the radius of the circle, or radius squared rather. No, radius because it's squared. Then k is the square root of k is going to be like the distance from the camera to like the edge of the circle, like the tangent. Like if you have like that circle and you're looking at like, what am I even saying? Okay, if you think of the circle as not a circle but a sphere instead, then this k is the distance, the square root of k is the distance from the distance from the camera to like the tangential intersection on that sphere, which I don't really see why this is important, but whatever. These are the fucking formulas. I don't know. I like my formulas better, but they didn't account for normal vectors, and normal vectors are a bit better to work with. Okay, whatever. Let's just do this. I actually kind of don't give a fuck anymore, so whatever. This one's wrong. I don't know. All right. Oh, and D is the dot product. So the distance between the camera and the plane defined by the normal of the circle. I don't fucking know. Whatever. Const A is equal to this shit. Const B is equal to negative 2 times D. Cx plus, Cx times ny plus Cy times nx plus 2 times k times nx times ny. Does that look anything like my B formula? What? Yes, it is. It's a function. What are you talking about? All right. Let's see something really funny. You do. There. What? You don't like that? What do you mean you can't find A? It's right there. It's right there. No. Oh, it's scoped. Fine. Have it your way. They're all 0. Oh god. Why are they 0? That is really not good, is it? Did I do this wrong? Well, D is definitely something. How big is width? Wait, this makes no fucking sense at all. Maybe they're just really small because it's really far away. Okay, if D is really big, then what is this? Dot product. Oh, I guess if the circle is rotating, it makes sense that that value is getting bigger because the normal. But what about K? Let's give this a bit more room. Okay, drop D. I don't want to see this. What am I looking at, bro? New line. No, they don't care about that, do they? K is a really big number, which I guess makes sense because it is, you know, very far away right now. Plate center, that is. Maybe that's too far. I don't know. We'll see. I mean, 500 pixels isn't that far, is it? We'll see. Okay. Okay, I need to. There we go. Much better. Much less annoying. Okay, so we got a few negative, low values. That's fine. All right, maybe A and B is not important. Let's talk about C. So this is going to be D times D. Yeah, I got something completely different, but that's because I derived these formulas without using the y, so it's obviously going to be very different. Okay, let's keep going. D times D minus 2 times D times cy times ny plus k times ny times ny. What do you got? Okay, that's a number. So y, the y squared has a fucking thing. I don't know. Oh, wait a minute. I just realized that this, I found this this whole A B C D E F equation is for a rotated ellipse, but this thing might not even be rotated. Not until we make y a bit more interesting. Oh well, let's keep going. D is going to be negative 2 times f. Oh, okay, finally f comes in. Okay, interesting. What is f? I'm so glad you asked. F is actually going to be constant to, it's going to be very constant. So f, focal length, this is not going to be changing unless we want to do some weird stuff with the camera, but let's just say this is focal length, right? It's not like some other bullshit. Focal length is, I don't know, it's what do we use here? Because this looks pretty good. Oh, this doesn't even matter. Does it? There's no way this matters. Because this is in, would it just scale? Focal length doesn't even appear. Distance, yeah, doesn't even appear at all. Okay, focal length is equal to, I don't know, 100. We'll see, maybe it breaks something, maybe not. But I'm also just gonna go ahead and grab that one as well. So we're gonna do const f is equal to focal length. Now you'll see why this is important. So we'll have f, 2 times f times d times cx times nz plus cz times nx. What is d again? It's related for an x variable. Okay, cool. Plus 2 times k, 2 times f times k times nx plus nz. And that works. Alright, so d gets a value, a really big one. Y. Just does, I don't know. Trust the process. Okay. E actually looks very similar to the previous one. This is f times d times cy times nz plus cz times ny plus 2 times f times k times ny times nz. And of course, because y is 0, ooh, careful there. There we go. Because ny is 0, this whole thing is going to be 0. which is why we're seeing that. This guy and this D thing is going to be equal to this, which is unfortunately not close to what I'm seeing here either. Oh wait, actually no, if we set y to 0, then we get 2f something, I don't fucking know. Alright, so this is, and then this is the constant factor, so we have f times we've got d times d minus 2. Well, I have an f squared, I'll tell you that, so at least that matches. Actually this is the closest one I've seen. So we have f squared times some something minus something plus something, so that's not bad. So d squared times 2 times d times cz times nz plus k times nz times nz. Cool. Let's see what that looks like. Okay, f is definitely something. F is definitely something. I'm pretty sure it should be negative, so this is a bit concerning. Did I get this right? All right. So believe it or not, this is everything you need to define an eclipse. You can actually plug these into Desmos right now and see this. Desmos, get a new one going. So let's see what values we have and if it's even worth continuing. So we have a is equal to let's see, 1, 2, 3, 4. It's these values. Pretty sure. A is equal to 2, 6, 8, 1, 4, 9. B is equal to 0. C is equal to 2, 4, 0, 7, 3. D is equal to negative 4, 1, 9, 8, 6, 2, 8. And E is equal to 0 because what the fuck is E? E is related to Y, and we're not rotated, I think. Yeah, because if we're looking at it straight on, it's not going to be rotated. If we move it over to the side, though, I don't know. And then we have f is equal to 1, 4, 6, 1, 5, 8, 9, 4, which looks ridiculously large, but I'm sure there's a good reason for it. So, and then we do ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to, and there, ooh, that actually looks pretty reasonable. It is much more reasonable than I thought. Very nice. Now, of course, there's no way to change these terms easily without completely messing it up, but yeah, I mean, that looks like an eclipse, and that is what an eclipse would look like if it was a circle projected onto a 3D sphere. Now you can change, or I guess you could try to change this, but it won't do shit. Let me really up this like 100,000, see what happens. Oh, yeah, see now it rotates a bit. A little bit here too. See what happens. Also a bit of movement there. Okay, cool. So we do have an eclipse. It works and it looks pretty reasonable actually. So we can go on with the next step then. How do I, like that? Oh no, I didn't mean. Wait, how do you? This this is actually relevant, but it comes in much later. This is some crazy stuff. I'll keep it open just to. This like really broke my head. This is just a parabola. All right, shut up. Okay, so we have A, B, C, D, E, F, which is great and all, but if we want to render in SVG, doesn't really help us. So how do we render an SVG path? I'll show you. The one that really helps is ellipse. We have Rx, Ry, x-axis rotation. These things, we'll get to them. X and Y. The thing that we're going to start with is X and Y. And actually, we might be able to plot this a little bit right now. Watch this. Let me just get an SVG going just so I can kind of show you a little bit of what we got. So what does an SVG even look like? Let's just sneak that one in real quick. Engine. Let's see what happens if we do this. Ooh, what? It was not happy with me. It's okay. Boom. Beautiful indentation right there. All right. So what we really, you got a problem, buddy? What's wrong? What? Did I mean stroke width? You're goddamn right. I did. There we go. And it looks a little funny. Height 320. All right, here's what we're gonna do. We're gonna fix this whole thing. Actually, we do not need all this fucking padding. So, where does this come from? Where is the padding defined? Because I'm getting a little annoyed, a little peeved by this. Flex, mini, screen W full, max W3XL, item center pi Y, PX3. Is it this one? No. Who's defining this padding? Wait. It's main. It's somewhere in main. It's one of these. And I'm just gonna get rid of these until it talks. Nope. That didn't do anything. Okay, what about you? That made it worse. Okay, that made it worse too. That made it better. Okay, max W3XL. That didn't do anything. Flex call. Definitely not. Item. Wait, that made it worse. That made it better. What is pi? Aha. Wait. Don't be shy. Okay. Well, that's reasonable. Let's just bring it down a bit. Okay. There we go. Now I can actually see what I'm working with. Alright, it's not. Wait. Still a lot of padding. What is this? Where is this coming from? Why does it hide when I... let's pop this one out. There. You. What is this? Okay, now it's within main. What is this? Oh, it's because it's centered, isn't it? There we go. I can bring that back. PY8. Boom. Much better. All right, now we can see the whole fucking page in one view. What a concept. Okay, stroke black, fill green. Let's do stroke white so we can see that. Cool. Okay, so this is a single path and it kind of has a fill. I want to get rid of one of these guys. And then we're going to actually do some crazy stuff with... $400, $300, $500, $600. 100%. Okay. Oh, I know what's going on. Okay. I'm just trying to fit it on the page, make it look a bit cleaner. In terms of height and width, I don't know. We'll do 1920 by 1080, except 192 by 108. Oh, that's too small. Of course it is. Okay, we'll have to scale it up a bit, I guess. Oh, actually, I just realized that this X and Y, it's not even the center. It's not even the center. It's just a point on the line. But I can still show you something like this. 0, 0. Wait, we move to 0, 0, and then we just draw a line to, I don't know, let's call it a... Well, I'll come back to this. We'll just draw a line for now. And we're going to need a... I'm going to do this. I'm going to do some insertions. So we'll just draw a line from... what did I call this? I called this x0 and... y0 and just draw a line to x0 and y0. See what that looks like. Cool. Looks like nothing because it's 0, of course. If I do, oh, wait a minute. SVG also needs to be translated. So it needs to be, if you're at 0, 0, you need to be moved into the center. So const SVG delta is equal to, we'll say 320, why not? And same thing here, and vice versa, and we'll just toss that in, plus SVG dx and SVG dy, SVG dy. Cool. And now, if we let theta be affected by this, it's not going to do anything yet. But you can think of this as like the center point on the circle. Now, watch as I actually plug in some values for x and y, because x and y, once we have x and y, we can figure out well, x and y doesn't help us figure out anything else, but we do need it for plotting. It is very important. So let's do this. So what is x and y? If we have this plane, we have this screen, x and y is going to be, okay, these equations I actually trust. So this is going to be b times e minus 2 times c times d divided by 4 times a times c minus b times b, which is, yes, that is the discriminant, kinda. And then it's going to keep the same denominator. But we're just going to swap those for y, and watch this. It's gone. Of course it is, because if you look at this ellipse, it's very close to the center. So, although no, it should still be drawing. That's weird. Let's throw in x and y and see what's going on here. Oh, and whoa, what the fuck was that? Oh, because it can't be negative, I guess, huh? But why is it? That doesn't make any sense. When we sketched it like this, it should be... Oh, this was just for 0, wasn't it? That is so weird. Did I not do this right? Oh, wait. Oh, sorry. B times D minus 2AE. Watch this. There. Whoa. Okay. How big is the width? This is very strange. Um, I think because it's doing this that we're too close to the camera. What if we moved it back by like 1,000? Make it 1,000. This should be more stable. This makes no sense. How big are these circles? What am I getting wrong? Because this is just the center. Like we're rendering the center of the sphere, and the sphere, it should just stay in a small area. Maybe we need to fix focal length. Make it like 1,000 as well. And let me also draw a line to the actual center. So okay, that's weird. Line to 160, 160. Okay, so this one is the center. Alright, well, we're still getting some really large values, which is kind of a bit of a red flag. Let me make sure I'm doing this right. No, that's good. I guess. Oh, is it because? Let me see if I can reason about this. So, we're looking at something 1,000 pixels away. No, okay. We have a camera. Our screen is 1,000 pixels away, and then we have another 1,000 pixels away. We have this plate. We have this plate that's spinning, and actually, you know what I can do? I can verify this with with the actual coordinates. So P, do another debug real quick. We'll do, what do we need? We need big circle center X. Let me just see what negative circle center X. That seems fine. That doesn't really seem to change much. Y, of course, is 0, and Z is a negative 1,000 away. That makes sense. It's like it's really far away. Now, first of all, Y shouldn't even be changing, by the way, because I think Y shouldn't be changing. It's 0, it's 0, it's 0, it's 0, it's 0, it's 0, it's still 0, it's still 0. Oh, okay. So Y doesn't actually change, it's just that somehow like the circle extends way beyond the screen for some reason. So maybe we need to make it even further away. Maybe like the circle's just that big. Let's make it super far away, like 1. Okay, if we make focal length really big, it should look more like orthographic. But then because it's so far away, what about 100? Don't know. Why is it like that? Okay, let's move the actual plate away, make it smaller. Don't, no. Oh my god. Okay, why is X so big? Or why is XY so big? Okay, XY is some, alright, reasonable. I think it's really just explodes, or it gets smaller, then bigger, and okay. Okay, let's look at the components of this. B times E. Oh. Seriously? B times E is 0. Okay, so completely ignore that part. It's not even doing anything. Let's just look at 2 times C times D. It's ridiculously... Wait. I don't even know. That doesn't really help me. What about 4 times A times C? Well, I'm not happy. I need to fix this. These should stay bounded. These should very much stay bounded. Is it... Let's see 4AC. 4AC is massive. B times B. B times B is 0, so it's really just A, E, and 4AC. Actually, if you simplify it, the real problem is... All right, let's pause this. Let's see if we can get some interesting thetas. See what we get. Okay, negative theta. That one's fine. Negative 0.1, 0.01. 1.2, 0.3. If we make it if we make it like 1.5, so close to pi over 2. Oh my god. That's still reasonable. Why'd it go up? Oh, because some value. Shouldn't it be, should be centered, right? Oh my god. I just realized something else. If it's... Yeah? Now it's centered. Okay, cool. Yeah, because it's like, yeah. Okay. Oh, wait a minute. Is it because it was offset by so much that it was going off screen? Because it was 100 away, right? X between was 100 away. And how do we fix that? Because was it really, is it, wait, I think that was it. I think that was it. It was just because the plates were so far away, when it spun, it would move the circle kind of like super out of bounds. But if we, I bet if we reduced this guy, we wouldn't have this. No, we do. Okay, fuck. If we refresh. So if it's just slightly off center, that doesn't make any sense. So let's bring down focal length. Alright, this is kind of hard to debug with just a single, what value is that exactly? 0.1? 0.01? What value is it? What is the problematic value? 8 point something? Let me make that a bit more obvious. Let me slow it down. Whoa, whoa, too fast, too fast, too fast. Two-ish? Why 2.2? Why is 2.2 a problem? It's not even like... .22. Oh. No. 2.23. What is 2.23? What is the significance of this shit? Okay, so is this what I think it is? No. Maybe. It's close to math point, but it doesn't really make sense. Like, why would that? Okay, so 2.23 seems pretty problematic. What causes this though? Which is what is big here? XO is 225, whereas just previously it was not that. This should not change it that much. Why? Because B times E is 0. B times B is thus 0 too. So negative 2 times C times D. Okay. 4 times A times C. Is, well, maybe C is not the problem because C is this is the problem, this relationship, negative d over 2a. Which one of these changes drastically if we just do this? Negative D is pretty stable. It's 2a. That's the problem. Why? Why is it? Alright, I need to take a quick break actually. Okay, I'm gonna mess around with the focal length and see if we can get something good. Oh. Okay, well, it still seems to swap signs around this value. Let me actually label these. Discriminant. Maybe these values are too large. Maybe we should deal with smaller values, like 1, and then, shut the fuck up. I think we should deal with smaller values and then just convert them into reasonable values when we get to SVG. So, because apparently floating point precision is limited. So, let's just do something like this. Const SVG scale. Now this is purely graphical. We'll come back to this in a later. For now, we'll just say 1. This is going to look absolutely tiny, but let's just see what happens. Focal length, I don't know. Let's think of each like unit as like a meter. So I don't know. Maybe if I'm looking at a screen a meter away, and then there's an object also a meter away, that should give me some pretty reasonable values, right? So let's just say focal length is 1. Let's say x between is also 1. Let's pretend these are meters. And also, if we have meters, we actually know the exact millimeters of these plates, so we can actually render them very accurately. Which I think would be pretty cool. Let's see what this looks like. Just out of curiosity, if we let this spin, it's going to go something crazy, isn't it? Yeah, the discriminant is just going all over the place, probably because the plate center is very, very far away. So let's bring it a little bit closer. A little bit closer. Maybe a little bit closer. Maybe -1. Okay, well, it's not flipping signs anymore, so that's good. X between 1. Yeah, let's scale it up a bit though. Let's SVG. Let's do SVG scale times X. Did you just see that? Weird. I guess it just lined up perfectly. SVG scale times. Okay, I'm seeing much more reasonable numbers, except for that. What is this? 2A. That's still pretty big, I think. I don't know what it means, but okay. What was that? Oh. Let me scale it up a bit. 10. 100. Okay. So for the most part, it should just look like this, right? Whoa, 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 whoa. What the fuck? No funny business, come on. Back you go. No, 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 no. Okay. So it looks like this, but then every once in a while it just goes. It's not ideal. Let's analyze a few of these. Same theta. It's a bit cleaner now. It's maybe 2.3. No. Let me slow down this. Reload and swap to this. I think it was like what, around 2 somewhere. Let's keep an eye out. Keep a sharp eye on it. Oh, this is gonna take forever, isn't it? Reload. Keep a sharp eye on it. Somewhere around. 1.5-ish. Is that pi over 2? That kind of makes sense. All right. 5. If we just slowly increment 0.01. 2, 3, 1. Oof, should not be going up that much. Yeah, it's math at pi over 2, isn't it? Some ridiculous number. Oh, no. Okay, we had something closer with this. Ooh. I don't like that. Alright. What's going on? What's going on here? XO is 12. Oh, we're in meters now. So if we're looking at a screen, somehow the X is now 12 meters away, which makes no fucking sense. Now, why is it that? Well, numerator is really low, and then discriminant is discriminant is right there. So swap these just to make it clear. Okay, so as we step, oh god, the discriminant completely changes. Actually, let me do this. The numerator and the discriminant completely change. If you up it even more, yeah, I think this is the weirdest one. Okay. Wait a minute. We, oh my god. These are millimeters over 4, right? Yeah. Pixels is equal to millimeter over 4. So we're returning millimeter over 4. So, if we want to convert this, this is so dumb. We need to const plate radius meters is equal to plate radius millimeters divided by 4. So this is so each one of these is 4 millimeters. So we divide by 4 times 100, which is so silly, but whatever. Let's see if this fixes it. So yeah, so basically we were trying to render a plate that was like 100 meters wide. So we're looking at like this, and it is as far away as we needed, but unfortunately the plate was also super far. So actually I think the previous values that we were using also weren't accurate because the plate was just so fucking big. It was like going into the projection plane, which would cause some weird stuff. So what we need is to do a quick conversion, and then everywhere we use plate radius, we're going to swap that one out real quick. Plate radius m meters. Okay, see, that's more reasonable. And then plate width, because right now if we just do it like this, we're going to have a very plate width m meters. Fuck. Why? Oh wait, no, wait a minute. Wait. If we have some unit that's 4 millimeters. Wait, no, we need to divide by 100. Because if we have 1 millimeter, we only have... Oh, it's 1,000 actually. It's 1,000. And then we have just times 4. Yeah, times 4 will get us to millimeters, and then divided by 1,000 will get us to meters. There we go. Now we have a much more reasonable thing. And this matches meters pretty accurately, actually. Okay, cool. So now let's let it run. Okay, moral of the story: do not let the plates go into the fucking screen, otherwise all hell will break loose. Let's see. Okay, cool. Let's speed it up. Rotating too slowly for me. 10 times faster. What the fuck? A little glitchy, aren't you? Well, at least the discriminant isn't being 0 anymore. Wait, what is going on? Alright, let's slow down the animation. It's clearly going too quickly. I mean, really, I should just be going in a little radius. Nothing crazy. Why did it just fucking jump? It's like barely moving, jumps. What is going on? Swaps to negative suddenly. Slow this way down. Something weird is going on. All I did was change the units. Okay, what was that? Right around 0.27, it just jumped. .27, 0.25, 0.28. Oh. Bit of a jump there, huh? Why would it do that? Doesn't make any sense. Maybe it's like some kind of... Maybe it's just some weird property that I'm like not seeing that happens when you have a circle like that. Whatever. I think it looks much more normal now. I mean, let's see if we can... Oh, it's projection, it's different. Or maybe that's just how it is. Maybe, Okay, let's let it run. Let's speed it up a bit. See, X... Okay, X does kind of move consistently, but then it just kind of jumps, doesn't it? And I feel like it has to do with... I feel like the eclipse itself is going to look fine, and we just need to start rendering it, and then it'll look a little bit better. But who knows? Maybe there are only like four. Alright, whatever, it's weird. Alright, ellipses are weird. Maybe... I have no idea. What if we played with the focal length a bit? Maybe make it 2. .5. 0.5 means we're looking at like this. Oh, so if focal length is larger, it should appear bigger. Interesting. Oh wait, but we also need to be careful. Oh, we need to be really careful, because if plate center is -1, plate center has to be beyond the circle, and we were just doing this, weren't we? It was basically on the circle. What a goofball. Alright, let's try -2. So focal length is 1, but then the circle is 2 away. In fact, let's even push it a bit further out just to make sure. Okay, that is odd. try again. Move further back. If I move something further back, it should be really small. So if I do 50, it should barely move. Yes. If I do like 1.5, all hell will break loose. How big are these damn... They're like this big, right? Oh. Okay, it just gave up on me. Plate center, -3, just to be safe. -4. Is it just taking a while to render? What is going on here? Why is it like jumping like that? Are we... Oh, we're doing some kind of integer stuff, aren't we? Let me convert everything to floats until we can get something. Yeah, let me just convert everything to float until we get smooth behavior. Still not it. Okay, the discriminant is jumping a lot. Why? The discriminant is jumping a lot because it's not this guy. It's not this guy. This guy's constant. No, it's not. The other guy's constant. At 0. So it's this guy. It's 4AC. That's the problem. The numerator seems pretty consistent for the most part. So jumpy, 4 times A times C. Okay. Yeah, this guy jumps a lot. Is it A or is it C? C seems pretty smooth. C makes a lot of sense, but A on the other hand. Ooh. Oh no. That is not good. That is not good at all. I think it's because okay. So A is a bunch of integers, right? Let me just make sure all the other ones are okay. Okay, everything is fine except for A, which for some reason just wants to be an integer because it's all a bunch of multiplications. Is it this fucking squared thing? Yes? That was it? Wait, you're... Wow, what a bug, huh? What a fucking... Wait, you're telling me that if I do something like 1.2 to the power versus... That's not even... close. Oh my god. Okay. 2 bugs there. Alright. 2 for 1 deal. Okay, I think let's make this thing rotate faster and just verify real quick. I'm just gonna save this. I know it doesn't really make a lot of sense, but doesn't look... Do not push this. Look like much, but progress. Alright, I'm not gonna push that at all. Page, just speed this thing up. 33 maybe, something, yeah. Or it is already pretty sped up. Alright, let's make it a bit more obvious that we're So you're rotating by bringing the focal length away. And we, yeah, cool, right? Also, okay, now X is not even changing. X is just barely twitching. Hold on. That shouldn't happen. Another bug, perhaps? Okay, well, X0 is X0, and it's barely moving. Why? Width is it because the width is so small now? What is this? What are we gonna call this? Plate width M? Ah, wait. Yeah, plate width is just 5 centimeters. So this would barely even register as like moving. Which I guess is but it should still go back and forth across the it should still go back and forth across the axis. It shouldn't just stay around 2 point whatever. I think perhaps, oh, it's this, isn't it? Boom. Now it's really small. Let's zoom in. Let's zoom way in on it. Let's make SVG scale like 1,000, 10,000. There it is. That's what I was looking for. Oh my god. Also, oh, and it doesn't go past the edge of the screen. It comes reasonable. Okay, one thing I do want to change that's been really bothering me is on this other guy. They're actually not really aligned. It's like the normals are different. So I'm just gonna do this minus so that this orthographic projection matches. So we'll do math.pi over 2, and that should just. Oh, and they're rotating the other way. Perfect. Or are they? Doesn't matter. Actually, doesn't matter which way they're rotating. Or does it? Wait, that doesn't make sense. Is it not the same theta? Boom, both at 0, and then both at maximum value right about now. Okay, cool. So just want to make that orthographic projection match what we have. Okay, fuck me, that took way too long. Okay, well, we have A, B, C, D, E, and F working, which is really the most important part. Now, next step. How do we have this shit working? Okay, we need to rearrange this A, B, C, D, F in such a way that D and E are D and E are 0. So that would mean that we get a new equation, which is not the actual ellipse equation, but it does center it on the origin, which makes the ellipse a bit easier to work with. So here's the next formula. Just fact checking this one. I guess that's one way to put it, huh? I don't. Well, Okay, I need to verify something once again. Here's the formula I have. This is a const. I call it f0 is equal to c times d plus a times e minus b times d times e divided by, again, we have that b 4 times a times c minus b times b. And there's another alternative that says f0 is equal to, oh, yes, very important, f plus 1/2 d times xo plus e times yc, or yo. Yeah. And is this correct? I guess, maybe, I don't know. If we flop this one in, well, I can see that it takes away that 4 times a times c minus b times b term. I can see that, but then we need to swap in b times e minus 2 times c times d. Then we have e times b times d minus 2 times a times e. And there's obviously a simplification we can do for the y equals 0 case, but whatever. Just looking at this real quick, this part is going to be, I'll just write it like this: dve minus 2cd squared plus dbe minus 2 dbe cd squared. No. AE squared, which yeah, that matches. Oh, you said 1/2. I don't believe it. Oh, I guess they're not that easy to compare. I'll have both of these ready just to swap it out, but I don't know. I like this one better. They're not that easy to compare because you have that kind of 2 dBE term, and you don't have that thing. But I'm pretty confident with this one. And, if we need to change it, we can just change it. Okay, next things. the angle, and the way to derive this is once you have this f0, you plug it back into the equation, and you have yeah, so you have ax squared plus bxy plus cy squared plus this guy as a constant, and then you want to find like a different set of units, such that if you plot the ellipse in those units, it won't be a rotated ellipse. It'll just be a normal ellipse, like 0 degrees and 90 degrees. So this f thing puts it on the center. Now we need to unrotate it, and to do so, we do a whole bunch of derivation. It is actually kind of annoying. We do a bunch of tricks to like merge them together, and the final result is this. I'll call it alpha, is equal to math.a inverse cosine of math.square root, which I don't really trust, but yeah, fuck it, whatever. Wait, did I do this right? Yeah, okay, so it's going to be math.square root of a minus c divided by math.square root of a minus c times a minus c, to avoid that bullshit, times plus b times b. Okay, so that's under the square root, and then we have that thing, and then plus 1 over 2. And that should be the, yeah, square root of the arc cosine. So that's the alpha, that's the angle right there. I'm just going to go ahead and plot it like so, and let's see what happens. This is going to be the rotation of the ellipse, which I think, because y is 0, this might just be 0. So let's see what happens. Oh, perfect. Oh, fuck. Oh god, no, that's not good. What is the... No, I don't like this. I can feel like oh, well, there's an alternative, and I'm pretty sure... Oh, okay, that was one of them. That was one of the options. The other option is you can solve this for arc cosine, or you can solve this for arc tangent. And the tangent one is a bit simpler, because it's also suggesting arc tangent squared, which is weird. X. Okay, so this has values. The problem with arc cosine is it does not have values. There's also arctangent squared, which only gives positive values, of course. Let's see what I have like 3 formulas for this. Let's try all of them. This doesn't rely on f also, so that's not the issue. There's math.a10. This one's much easier. For some reason there's 2 of them. I don't know why. They don't look equivalent either. Math.a10. There's simply just b divided by 2 times. Oh, never mind. We can't do that one. That one's too easy. Too easy. Wait, actually. Okay, let's do this one instead. I trust this one. A minus c plus math dot square root of this thing again. Plus b. Oh no no none of that. Boom, square root number. There. Okay, alpha is 0. That kind of makes sense. The only thing is I do want to try, if we just mess with the y a little bit, just a little bit. Okay, I'm just kidding. Okay, so alpha does change. Ooh, what the fuck is going on there? Y is... All right. Okay, what's up with y? What's the problem? What's going on here? There's an issue. There's an issue with c, isn't there? Okay, let's talk. Let's talk about this. Y is negative because of course not. Well, no, that makes sense, but why is it being rendered like that? Oh, it's just an issue with the SVG, I think. But why is it like that? Why is it... No, wait, y is correct. Y is correct. Oh, because we need to... no, that's also correct, actually. Because SVGs go in the negative direction. Nope, that's not it either. At least it's not jumping. X is that way. If we scale it, we need to scale it negatively, don't we? Say minus? I'm just gonna try a few things until it works. I don't... Definitely not that. Plus. You're gonna have to help me out here, buddy. Y is negative 0.05. So what should happen is y should be multiplied by SVG scale All right. So negative, wait. Seriously? Oh, it's because we're way zoomed in, isn't it? And we just set the y way up there, didn't we? Okay, let's zoom out a bit. Okay, now y is, okay, no. Y is positive, so it should be up. Okay, so I think I was right here. Yeah, there we go. Cool. So now we have this little plate rotating a little bit, and alpha is changing ever so slightly because it is. Just trust the process. Looks pretty good though. I kind of trust that y is different. In fact, I'm actually gonna tilt. Oh god, this is gonna make this complicated, or is it? Whatever. We'll just call it this. Const tilt down is equal to 0.1. Just tiny little rotation down. Just check this out. And of course, this is gonna fuck up everything, but I think it's math dot cosine of tilt down. And do the tilt down, and we're gonna do the exact same thing here. And we're gonna do this is just gonna be math dot sine of tilt down, right? Tilt up, and we'll do negative. Gotta be clear, gotta be very careful with these. Very careful. And I know there's like an actual term for this, but I don't give a fuck right now. So now the plate is like, it's a little bit up, it's tilted up, but it's still, what is it rotating around? It's rotating like this. Like it's rotating like that. Or it's looking down a bit, and it's like rotating like that. So that's what we should see once we actually render it, but I just wanted to just test out that alpha is indeed changing as we change it, as we modify y. All right, cool. So alpha, for some reason this one works. Did I derive this one? Yes, I did. So let me just check this real quick. There's another one which is this, and I'm honestly not convinced. It's equal to math dot atan squared. Actually, something divided by 2, and that's going to be something like that. Actually, the way it's written is a little off. What is this supposed to be exactly? Huh? Wait. What is it? Oh, I feel like that's kind of cheating though. I don't know, it just doesn't seem right. Oh, this isn't tangent squared. This is just an alternative way to do it. Why is... I'm not convinced. I'm not convinced at all. But apparently you can just do that. And it should give you the same value, but I still think we need this though. right? Don't we? Actually, I do think I trust this one the most because this is a full division that we don't really need to make. But it does seem to be about... Oh no, wait, that's different. Why is it different? That is very different. That is like half. Oh, because it's supposed to be divided by 2. Is it though? A figurative. Are these two the same? Shouldn't jump. Nope. But why? I mean, I like this one because I actually like figured it out, but arc tan half formula. Wait, let me see if I can figure this out myself. Let's say you have alpha is equal to arc tan something over 2, and then you have 2 alpha is equal to arc tangent x. X is equal to tangent of 2 alpha. So what? Oh, what the fuck? Oh, actually, that kind of looks like... That actually looks a lot like what we have. That looks almost exactly like what we have. Except... 1 plus x. Oh. Wait. Huh? Except replace the 1 with a what? B? Yeah, so if x is b here, and then 1 is a minus c. I don't know. I don't trust it. Something's off. I like this. It seems to be right. If we need to optimize it later, we'll maybe do something like this. But I'll stick with the square root because it looks right. All right, cool. So we have arctangent. Cosine wasn't working because our cosine is very limited. Okay. So that'll give us the angle, which we can actually use now. We can actually use this. X-axis rotation. So we're about to get the length of the x-axis, but for now we can just do this. So let's think about this. So we have this line. We move from 0 to 0 to there. We're also just drawing it to the middle just to make it clear where the middle is and offset it. But what we can do is we can draw a line to the center of the fucking thing. The center of the fucking ellipse. Then we can move in the direction of the rotation. So we can use that alpha right now. So we'll do move to L. Okay, we need to think about this a bit more carefully, but this is going to be good because we're going to need this later anyways. But we're going to do const SVG x, and SVG center x is equal to SVG scale times XO plus SVG dx. And same thing for y. And then we can do, we'll just offset it a little bit. We'll do const SVG cx And if we're rotated from I guess this will be like if the oval is rotated, this is like the 0 angle on that. So we'll start at like 0 angle is equal to, we have an x and y coordinate. We'll do this. We'll do this. We'll do this. X is equal to, what is the direction that we need to move in? The direction is cosine alpha sine alpha, and then that means that x is going to be SVGC x plus, let's just say, we don't have these values yet, so we'll just plug in 10 times math.cosine alpha, and then we'll have the 0 angle y will be same thing for y plus the there. Okay, so now we can move from that line to another line. We can replace this with a simpler one. We'll just call it SVGCX, SVGCY, and we'll move to SVG0 angle x and y. 3, 2, 1. Now this looks weird. What is going on here exactly? I'll tell you what is going on here exactly. Actually, that does look really strange. What the fuck? I feel like there's. Oh, that's why. Wait, but those two should be the same, no? Oh. So let me. Now, okay, that should only be 3 lines. Cool. Get rid of this one real quick. Okay, now it looks the same. Okay, 0 angle x and 0 angle y. Now from there, I want to draw a curve to the, let's call it pi angle. So this is going to be same thing, but in the opposite direction, in the same angle. So we'll do minus, minus. Okay, and we just plot what that looks like, and you might actually see a bit of rotation at this point, but this is not exactly what we want to do. Or let's call this pi angle for s pi. Boom, and then we'll do. We actually want an arc here, and the exact rotation and all those parameters of the arc will be given shortly. But for now, I just want to see what this looks like. Ooh. Yeah, that's pretty hard to follow. Let's just start in the middle. Now what does this mean? So we're moving from the center to the center of the ellipse, to one end, to the other, and then back. It might actually be a bit more obvious if we do this. There it is. There's our beautiful, beautiful ellipse. Now, we actually need to go, from offset to the pi angle back to the 0 angle. So let's do, so this can be a line, but this one and this one, these need to be arcs. Now, this is where it gets fun. This is what an arc looks like. I'm pretty sure we need all of these, so let's do A. This is radius of x and radius of y. Again, we don't really have, we're about to get these values, but we don't have them quite yet. So let's just set them to like, let's make the x thin so you'll really see an oval. So, and I think these are relative, so 2, and then y-axis can be 3. Rotation, Rotation we have. Rotation we have. We can use it. Alpha. That is going to be alpha. It might be like in the opposite direction. Maybe. I'm not sure. Large arc flag, sweep flag. No idea what these are. Let's just set them to 1. And yeah, same thing here. And let's see what happens. Let's make it more obvious. There it is. There. Okay, why did I get small? Why the fuck did it just get small? That is a little interesting. Oh, because we're not calculating the things correctly yet. But maybe you can see the vision now. Let's see if we can mess around a little bit with this. Now, let's say, what happens if we move it away? What happens? Actually, it's not gonna look interesting. If we move the plate center Y a little bit up, it should go up. Maybe not that much. That seems a bit off. How far is it away again? It's not too far away. Just a little bit. Oh, because we're way zoomed in, that's why. We're way zoomed in, but the width shouldn't have an effect on this, right? I'll say plate width is just like ridiculously huge, like. Okay. Does that at least make sense? Huh. Actually, it should be way more broken than that, but whatever. Imagine like. Well, this will be easier to imagine once we actually have it working. So let's go back and move it down a bit, back to 0.1. We zoom out a bit. This is just scaling. It doesn't really matter too much. Okay, so we have this little eclipse guy, and this roughly corresponds to, well, nothing, because the axes are weird as fuck right now. Okay. Wait, it's not even rotated. Why not? It should be rotated, though. That's the thing. Okay, that's a little concerning. Oh, I know. Because this is in degrees, isn't it? This is in degrees. So we actually need to multiply by... okay, that's fine. We can just do const SVG rotation is equal to alpha times... math dot pi divided by 180. No, divided by this times 180. P21. Well, because we're not using it. Please. SVG. This is what I want to see. This is more important than the. Okay, maybe not quite like that, but you get the idea. Well, no, that's actually kind of what it would look like. We would change the things, but the circle would go from like that to that. So yeah, that actually does look like what I would expect it to look like. Sweet. We got SVG rotation working. My God. All right, next up, we need some important intermediate values. Very, very important intermediate values. We're going to call these, I don't even know what to fucking call them at this point. Where were we? This is the SVG stuff. SVG stuff. And then we can do const, I call this A1 is equal to A plus C plus math dot square root of, again, this thing comes up again. C plus B times B. So that's square root of this whole thing goes under 2. And a C1 looks pretty similar, except it's just minus A plus C minus. Now what do we need these for? I'm so glad you asked. These major axes, remember that F value? Well, if we just do this, math dot square root negative, wait, is it F0? This is where this guy comes in. Yeah, I didn't think we'd use it, huh? Divided by A1, and we do semi-axis B divided by C1 basically, what are we doing here? Now that we have the rotation angle, we can kind of substitute in some values to plot the eclipse as if it was unrotated. And then once we have it in that form, we find some values, so these values, in such a way that we have basically A1 x squared plus C1 y squared plus F0 equals 1. And once you have that, then you just swap it around and you get the axis lengths, which is huge, because now, believe it or not, we can actually do this. We have const SVG, semi-axis A. So this is just length. This is just a scalar. Semi-axis A times SVG scale, and vice versa for B. And now, the one you've all been waiting for. We replace this 1 and 3 with the actual values. Now we might need to swap them. I'm not sure. This might look weird for a second, but I'm pretty sure this is exactly what we need to be doing. And swap that to B, and watch this. Whew, okay. What the fuck? Damn it. So close. Oh, right. Silly me. So we're not going to do, we compute these earlier actually. We have x, y, we have the center, we have the axis. Now we're going to compute the 0 angle. So this depends on semi-axis. So it's not just going to be, oh wait. We need to move these in the direction of one of the axes. I don't know which one, actually. I have no idea. Let's see what this looks like. Semi-axis A and semi-axis A as well. Basically, we need to go move along one of the axes. I don't know which one, though, and these might be wrong, but... Reload? Not quite. Oh, because we have this. And please, please, please. That is an oval. That, my friends, is an oval if I've ever seen it. Holy shit. Oh my god, that's actually oh my god. Holy fuck. Holy fuck. That is insane. That is insane. It looks right. I'm not a like oval expert, but the only thing is I think let's make the width larger just so we can see that like it moves in 3D. Oh my god. I have been cooking on this for way too long. Let's just make width like 2. So big wide cylinder. Maybe this will move it around a bit more. Might be a little hard to see, but so I need it to be like, so when it's closer to the camera, wait, focal length is 2. If it's at 4, that's gonna be a problem. Let's make it 5, and then we'll do with 3. Make it really thick plate. So I think it's far away now, but then as it comes closer, we're messing up the axes. Oh, yes we are. Yes we are, aren't we? Because it's always we mess up the axes, but it's okay. All we need to do is determine which one is the minor axis and the major axis. So const minor axis. This might get some weird rotation stuff, but we'll see. Minor axis is equal to semi-axis A less than or equal to semi-axis B, question mark, if semi-axis A else semi-axis B, and then we'll do it the other way. Major axis, please work. Okay, this doesn't do anything, but let's just move it along the SVG major axis and SVG minor axis. I guess it doesn't, for rendering purpose, I don't think it matters if we move along the minor or major axis, as long as we get the ratios correct. Like sometimes the x axis will be bigger, sometimes the y axis will be bigger. Let's see what happens. Minor axis and major axis, and that we'll move it along the SVG minor axis. Same thing here, here and here. So you see that little line? That line sometimes might be, it's always the shorter axis. It's always on the shorter axis, but maybe I have no idea. Let's find out. Semi-axis A. Wow, what's wrong? That's not very helpful. You're gonna have to try again. Here we go. I have no idea. SVG minor major axis. think as long as we're consistent. Ooh. What the fuck was that? Well, yeah, I guess at some point it'll like look ridiculous because it's like the circle is basically aligned onto the sphere, but this doesn't seem right either. Um, um, X-axis rotation. I have a feeling that I think this has to do with alpha. I don't know. Wait, semi-axis A is kind of like the x-axis, right? And then alpha is rotation over the over the other axis. So maybe this is just like the rotated x-axis, not the semi-axis. I mean, what if we did this? I mean, I'm pretty sure that this is like A, right? This is like semi-axis A, and then we do semi-axis B. I think this will get the ratio right, at least here. It shouldn't be that big, though. And why is semi-axis? We need to move it along. I wonder if that's the problem. But this seems correct. This seems correct. FEJ. There's no major axis. Fuck off. Okay, if we make the radius small and the width bigger, I think we might be able to see what I'm trying to show. Or better yet, since we have one working, what if we just get the other one working? Then we'll be able to verify. Um, okay, let's try that instead. So we have export const circle. It's like circle as SVG. So SVG circle. This specifically needs to be a path because we're going to put them all in the same thing. Shut the fuck up. Is equal to, we need this, and yeah, okay, circle properties is equal to return this fucking thing, D8D, D10D, D14D, yes, and we'll do return, paste. Okay, now how do we actually get there? We need to back up a little bit. Const, all this shit comes from here. No. Yes. CX, CY, CZ, NX, NY, and NZ, radius and focal length is equal to circle properties. And that's all you need to define a projection of a circle. Okay? Man, shut up. I'm not downloading anything. Okay, from here, let's move all this into, we can do this somehow. We'll get there, let's just move all this stuff into here. So this is all we needed to do to get all that stuff. I do want to see what happens if we swap the axes though. Okay, if we swap the axes based on which one is which, so we let them be a let. And we'll do if semi-axis B is greater than semi-axis A, then I think the way to do this without an intermediate is you just do this: semi-axis A, semi-axis B is equal to semi-axis B, semi-axis A. Let's see what happens. Okay, so now now it's always on the longer side, which, okay, bye. Might not be what I need either. Why is it always on the longer side? What, is there like a mathematical thing for this? Maybe we need to do like if alpha is a certain, wait a minute. If alpha is at a certain, like, if it's at a certain rotation, if something is negative, something has to be fucking negative. I don't know what though. I guess it's like if it points in one direction or the other. Wait. X-axis rotation. I don't know. I'm a little bit weirded out by this, but let me check some of my notes. I don't. I think this doesn't even matter. Let's increase the width. I want to see what happens. Wait, it is increased. Oh, right. So when we were messing around with it, it didn't actually change anything. We need to change this one. Make it half a meter. Nice. 5. Whoa, and then bye. You see, one should be much smaller than the other. Like on one side, it should be smaller. Okay, so it should be bigger or smaller as it comes around. Maybe it would be more obvious if we were looking at it closer. That wouldn't change anything. Oh no, it will. It will. Bring it closer. 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 So top is right about here. So this is the closest it gets to us. Yeah, it's barely making a difference. Or is it? Okay, see this like touches, this just touches the bottom of the mouse, but then as it goes around again, it doesn't. It's working. Woo! Sweet. Okay, cool. Perspective works. Beautiful. Next up. Did I not? Okay. Okay. So if you think that was hard, wait till you find out. Actually, let me put the other one, the other uh, thing in first, and then we'll figure this out. No, not quite my tempo. We didn't bring in the. We need all this. Did I just? Okay. So all this can come from. Ooh. What if we did? What did we call it? SVG angle? SVG circle? It's not really a circle, is it? It's not a SVG circle. What do I call it? Properties? Circle properties. Or oh no, wait. This is gonna get really complicated. I think what we really need is just that string. So this isn't gonna be like, this does not need to be, we don't need this. We just need the path. There. Or not even the path either. We just need a, oh, I have no idea actually. I don't know. Let's return a few paths, then we'll kind of smooth them out a bit. So, shut the fuck up. We'll do const path is equal to SVG circle, all this stuff, all this beautiful, beautiful stuff. I know, hold on. SVG path, D is equal to path. Close that out. A whole bunch of stuff's gonna break. It's okay. What? Why didn't you like that? What's wrong? What? Oh. Okay. I spelled it wrong. Okay. SVG circle, and you will be my. What do we need again? CX, CY, CZ, NX, NY, NZ, R and F. Beautiful. I'm gonna pretty much take everything here and just get rid of it. Okay. What's wrong with you? Cannot find variable y0. No, I guess not, huh? We don't need it anymore. Congrats. Actually not gonna be able to find any of these anymore. Nope. Don't need that. Cool. Maybe we'll bring them back. Probably not. Okay. Well, this actually makes it pretty easy because we can just do. Params. Please tell me that works. Oh, oops. No, what are you doing? Oh, I'm sorry, I forgot a fucking line. Sue me. Okay. A few things I want to pull out is SVG scale. These can be constants. Now we have a beautiful method for creating these ellipses. Now let's make another one. Actually, now that I think about it, we are going to need some intermediate values from that. So I think we do need to return A, B, C, D, E, F. Okay. This should probably return more than just a path. Probably return a whole. It should probably return A, B, C, D, E, F, XO, YO, alpha, axis 1, axis 2. Then we can really work with it. But let's just do this. That's on one side of the circle, but we're also gonna need another one, and we can do. No. What are you doing, bro? What the hell? This one's pretty simple. We're gonna do. The only difference is big circle center X, Y, and Z. And I'm just going to hard code these in. Plate center X minus plate width in meters divided by 2 times normal X. And vice versa for these two. So Y, Z, Y, Z. And we now have 2 paths. And we can just do I think you could just do this. Fingers crossed. Did I miss something? The path is move to the center. What is going on here? Something's not right. How do they both disappear? That is really strange to me. And I'm actually not even. They really should not be disappearing like that. Swap them. What the fuck are you doing? What? That is even weirder. What did we set the width to be? 0.05. I think the plate's wider. Maybe not that wide. I don't know. Mess around with this directly. Move them back. No, I don't think the axis swap thing is correct. Maybe it's this. I like that they just disappear. Like, how does that make sense? There's gotta be some kind of weird. Why are they disappearing? I don't get it. Let's zoom out. Make it wider. How about this? Let's get rid of the move to center thing. We'll just move directly to the what? Mm. I don't like that it's disappearing like that. I still think something is wrong with the axes. Oh, do we need to do... Maybe? No, it doesn't change anything. Alpha is arctangent, right? No, it's definitely not that. Need a break. Okay. I think if we swap the axes, we also need to modify the alpha, because we have like that, and then we kind of made them different. So maybe I think that's what's going on here. So we also, I guess, yeah, we need an SVG rotation. SVG rotation. Get that a little bit higher up. Is equal to, I don't know, SVG. It's not going to be a constant anymore, but SVG rotation plus 90. Did not like that. What the fuck? Okay, something is something's clearly off. Something's clearly off. I'm gonna hard code the theta again just so we can mess around with this a bit. So at something like, let me zoom in a bit too. 300. Okay. So at a theta like pi, for example, I don't know. Doesn't seem like a crazy one. I don't know, pi plus something, so maybe like 4. If we set theta to 4, what happens? 4, 5. I don't know, seems a little far from pi to be just completely not rendering. So I say we just go ahead and investigate what the fuck is going on with the path. What do you got? Oh, perfect. Okay, that's what I thought. That is I mean, fair enough, but what the fuck? I think we can do something like, first of all, why is x 0? Like, look, we have a, okay, no. SVG 0 angle x. Why is that not a number? Why is that not a number? If this isn't a number, let me go there. If this is not a number, and this is derived from probably one of these two, math dot cosine alpha. So either x-axis or alpha is empty. So let me do, I think you can do this as a kind of sneaky way. If true, return, I'm just going to return a string. x-axis. Is this the problem? What? Sorry. Sorry. X-axis. Oh, cool. Not a number. Is alpha at least a number? Alpha is a number. Is SVGCX a number? Yes, so it's just x-axis. Why? Okay, is SVG scale null? No. Is semi-axis A null? Yes. Why? Because it's the square root of negative f over a1. Is alpha at least fine? I think an easy check for this is alpha, if we set the y thing, where's the y? Where's the y value? Down here? If we just set tilt up to 0, there shouldn't be any y trickery. Even less, and then if we get rid of this, no y trickery. Okay, so that the alpha seems fine. That's not the problem. The problem is this guy. It's probably FO. Why is FO? Why are you positive? Shouldn't you be negative? What about A1? A1's fine. Okay, so why is FO positive? Is my formula wrong? Should I use the other formula? Okay, I care more about rendering these fucking cylinders than I do about this. What's wrong with you? Nope, looks fine. What? Oh, sorry. Okay, now it's negative. Okay, what? See, this is how to get you. If you get amazing. That was the issue. That was the issue. Oops. Whoops. Okay, get rid of that if true. Let's go ahead and render that path. That looks better. At least it's showing up now. Oh my god. Don't disappear. Don't disappear. Wow. Oh my god. That was a bit weird. I think the further one might be closer or something. Wow. Holy fuck. It is a it is a little something seems a bit off. I think hmm, maybe there's some kind of other sign we forgot here. Hmm, maybe we don't need this. Let's see what happens. Maybe not quite it. We still need this one. Oh, it makes sense if you think of. I'm just gonna keep my mouse on the rim. If you think of this one as oh, but then it's rotating the wrong way. God damn it. Okay, we can probably fix that with something like. We're so far down the rabbit hole, I don't even know. Um, I want it to be rotating this way, but it's actually rotating the other way. So that. Must be somewhere we're using NZ wrong. Or does it have to do with the fact that um, SVGs are like negative? So, oh, okay. Let me see if I can do this. Yeah. That's got to be it, isn't it? Because um, yeah, we need to like flip it because if we okay in our plane, if we go up on the y-axis, okay, on a normal screen, if we go up on the y-axis, we need to go down in the SVG axis. So every y thing it needs to be flipped. So let me um, this is where we start getting into SVG stuff right here. And if we flip it, that'll also fix the rotation thing. So I was correct in the yeah, normal Z. Right? Yeah. Wait, but if we flip it, it's going to keep rotating the same way, though. It's only if we mirror the x would it do anything. Which the x also needs to be... Oh, wait, is it... X positive is right in both directions. I don't know, maybe... Yeah, if you're rotating like this and you mirror it, you're still rotating that way. I don't know. Okay, SVG is going to be SVG scale minus. No. Y0. There. For both of them, please. Or is that right? Why did it only change one? That's weird. I don't like that. I think the SVG... This is scalar. This is scalar. SVG 0 angle y. Math dot sine alpha. I think this needs to be minus. No. Now we'll make it work. Hold on. It's still rotating the wrong way though. And all we did was fuck it up from the center. Let's see what happens. Let's try increasing some of the directions. Like, damn it, I have it and I want to mess around with it, but I don't have time now. Plate center 2. That goes down. That should... Okay, well, we still have something wrong because that should be going up. So something's still off here. Okay, if CY increases, I think it's as simple as just XY. Why is Y? What's wrong with Y? Where's Y0 used? Y0 is used here, here. That should be all we need. All right, whatever. I need to take a break.